Okay, welcome back everybody. In this video we're going to talk about standard form of a linear equation and graphing, how we can use standard form to graph a linear equation. One of the benefits, quite frankly, in my opinion, it's the biggest reason why we even talk about standard form in these days, is how easy it is to find the x-intercept and y-intercept of a graph. So if I have an equation in standard form, if I want to find the x-intercept, all I do is substitute 0 into the equation for y and solve for x. And this will be a very easy calculation for us if we're in standard form. Same thing to find, typo alert, to find the y-intercept, we substitute 0 into the equation for x and solve for y. So also, when we're in standard form, this will be a fairly simple calculation. So let's take a look at how this works. The x-intercept, we're going to put 0 in for y. And if we put 0 in here for y, it turns into 3x equals 12. And so just divide both sides by 3, we get x equals 4. That makes our x-intercept the point 4, 0. And we'll do the same thing, except flip the script. To find the y-intercept, we'll put 0 in for x. And then take this equation and solve it, and that'll give us the y-intercept. And again, an easy calculation, 12 divided by negative 4 gives us negative 3. So our y-intercept in this case is going to be 0, negative 3. Alright? And there's how I find my intercepts. Now, in all honesty, all of this work over here that I just showed, I'm really not ever going to do any of this, or show any of this. Instead, what I'm thinking is, when I have an equation like 2x plus 5y equals negative 20, and I'm trying to find the x-intercept, I'm just going to get rid of the y's, and that gives me 2x equals negative 20. I divide both sides by 2, and I get x equals negative 10. And so my x-intercept is going to be negative 10, 0. And then same thing, only in reverse. When we're finding the y-intercept, we're going to put 0 in for x, which gets rid of that term. And now I have 5y equals negative 20. So divide both sides by 5, and I get y equals negative 4. And so my y-intercept is going to be 0, negative 4. Alright, so that's how we find the x and y-intercept in standard form. Let's look at actually using that in graphing. So first we're supposed to find the x-intercept and y-intercept of the following, and then we're going to use them to graph. So first I'm going to identify the x-intercept and the y-intercept of this graph. Okay, the x-intercept I get by putting 0 in for y. So I've got 2x equals 10, and my x-intercept is going to be 5. And then I do the same thing. I put 0 in for x. I get negative 5y equals 10, so y is going to be negative 2. And one of the benefits of writing our intercepts like this is it kind of stresses to us and reminds us that each intercept is an individual point. And we're going to use those when we graph. It's going to give us 2 points with which to graph the line. So I'll graph the x-intercept. It's at 5, 0, right here. And then I'll graph the y-intercept. It's at 0, negative 2, right here. And then I will break out my handy-dandy ruler and draw the line through those 2 points. And there's a quick, easy graph of the line using the fact that it's in standard form and using the intercepts. I mean, we know how to graph in slope-intercept form, so I always have the option to convert this into slope-intercept form. I just think it's easier and faster when you have an equation in standard form to identify the intercepts and graph it that way. So let's go ahead and look at part B here. We're going to find the x-intercept and the y-intercept. Okay, and so first I find the x-intercept by putting 0 in for y. That gives me 4x equals negative 12, so x is going to be negative 3. And then I do the same thing, same strategy for finding the y-intercept. I put 0 in for x, and that gives me plus 3y equals negative 12, so the y-intercept is going to be negative 4. Then I'm going to plot those 2 points, negative 3, 0, 0, negative 4, and then I'm going to break out my handy-dandy ruler and go ahead and draw the line through those 2 points. And there's the graph of the equation, 4x plus 3y equals negative 12. Okay? That's how easy it can be to graph using the x-intercept and y-intercept in standard form. One last example, a quick little application. We're told here slices of cheese pizza cost $2 each, and slices of pepperoni pizza cost $3 each. A baseball coach spends $36 on slices of pizza for his team. The equation below shows the relationship between x, the number of slices of cheese pizza, and y, the number of slices of pepperoni pizza that the coach will buy. So there's our equation right there. I've underlined it in yellow. 2x plus 3y equals 36. Part A. If the coach doesn't buy any slices of pepperoni pizza, how many slices of cheese pizza can he buy? So I'm going to go back to this same idea. Let's see, we want no slices of pepperoni pizza. Y is the number of slices of pepperoni pizza, so we want y to be 0. So the y term is going to drop out. We get 2x equals 36. He can buy 18 slices of cheese pizza if he doesn't buy any pepperoni pizza. Okay, and in part B, if the coach doesn't buy any slices of cheese pizza, how many slices of pepperoni pizza can he buy? Okay, so now in this situation, instead of y being 0, x is going to be 0 because x represents the number of slices of cheese pizza. So that's going to be 0, and we get 3y equals 36. We divide both sides by 3. We get y equals 12. And so he can buy 12 slices of pepperoni pizza if he doesn't buy any slices of cheese pizza. Okay, a little bit more on standard form in this video, and also how we can use it to find intercepts, x-intercept and y-intercept, use it to graph equations, and use it in an application like this one. Alright everybody, that's the end of this video. See you guys next time. Have a great rest of your day.